Fluency is not the same as truth. A language model is optimized to produce plausible, well-structured language. That's a genuine strength, but it is not the same as accuracy, professional judgment, or ethical responsibility. And in our field, that distinction is everything. Hello, and welcome back to Season 2 of Beyond the Couch, AI and Psychology. I'm your host, Dr. Ernest Wayde. As always, before we dive in, I want to thank the organizations that make this podcast possible. This episode is sponsored by the American Board of Professional Psychology, the National Register of Health Service Psychologists, and my consulting firm, Wayde AI. Their support allows us to keep having these psychologically focused conversations about how AI is shaping our field. All right, so last time you and I talked, we talked about what AI is doing to us, how it's changing the way we write, think, and work as psychologists. We talked about cognitive load, validation, and the risk of fluency bias. I use myself as a running example because I've been using these tools constantly for years across a lot of different domains. And I got a lot of feedback on that episode, so thank you for that. People found it useful, but a theme that kept coming up was this. I get what it does to me, but I really don't understand what it is doing. What is AI actually doing? What is actually happening inside of these systems? When I type something into ChatGPT or Claude and I get an answer back, what just happened? So that's what today is about. And I want to be upfront about something before we start. This episode is going to be a little more technical than usual. Not deeply technical. I'm not going to go into math or code. But I am going to walk you through what's actually happening inside these systems, step by step. Because the more you understand how these tools are built and how they generate responses, the better equipped you are to use them responsibly. So, we're going to cover two things today. First, how large language models are trained. And second, how they actually generate a response when you use them. Two separate processes, but both important. And once you see how both work, I think a lot of things about these systems, including their limitations and their risks, will make a lot more sense. Let's start with training. To understand how these systems work, you have to start at the beginning, which is training. Because unlike traditional software that is explicitly programmed with rules, large language models learn. They learn from data and everything about how they behave, what they get right, what they get wrong, what biases they carry, traces back to how they were trained. I want to walk you through 5 stages of that training process. And as I do so, I want you to think not just about the technical steps, but about what each stage means for how you should trust, verify, and use these tools. Everything starts with data. Large language models are trained on massive amounts of text, and I mean massive. We're talking billions of documents, web pages, books, articles, code, research papers, forum discussions, social media posts, the list goes on and on. The data comes from publicly available sources, licensed material, and text that is intentionally created or curated for training. That's right, they actually create content just for training purposes. Now, here's the first thing I want you to notice. The model doesn't choose what it learns from. Engineers do. And those early choices, what sources to include, how to weigh them, what to filter out, shape everything that comes after. The model has no way to independently evaluate which sources are more credible or more accurate. It learns patterns based on what it sees most often. So when we talk about bias in AI, and there is real bias in these systems, it doesn't get added later. It's baked in from the very beginning through the data. Missing perspectives, overrepresented viewpoints, cultural blind spots, all of it gets encoded before the model has even started to learn. Before a model can actually learn from that data, the data has to be prepared in a way that a computer can work with. This stage is called pre-processing. The text gets broken down into smaller units called tokens. A token can be a whole word, part of a word, or even just punctuation mark. Each of these tokens is then converted into a number because ultimately the only language computers understand is numerical. Now, that conversion has consequences. When you break down human language down into numbers, you lose some of the richness along the way. Tone, Nuance, cultural context. These things are not explicitly preserved. They have to be inferred statistically later. And when you're dealing with emotionally complex, clinically sensitive, or culturally specific language, which is exactly what we deal with in psychology, that's a real limitation. Once the data is prepared, the model starts learning relationships between the words. This is called the embedding stage. Here's a simple way to think about it. The model takes all those tokens and places them into a multi-dimensional space. Imagine a giant star map where words replace the stars. Words and concepts that tend to appear near each other in the training data get placed closer together on that map. So if the words depression and treatment frequently appear together in the training data, the model learns to associate them. But, and this is critical, that association is based entirely on patterns of co-concurrence, not understanding, not meaning. The model has no idea what depression actually is. It has no lived experience, no clinical training, no empathy. It has learned that certain words tend to appear near certain other words. That is the foundation of its internal map of the world. If certain ideas appear together frequently in the training data, even if those associations reflect cultural bias or incomplete information, the model treats that as meaningful. That's not a bug, that's how it's designed. But it's something you need to understand. So when you hear people say the model is hallucinating, that's us anthropomorphizing the model. But really, it's doing exactly what it's meant to do. Once the model has built its internal map, it moves into what is called pre-training. This is the core learning stage, and the task sounds deceptively simple. Predict the next word. That's it. The model is given a sequence of texts, and it tries to predict what word comes next. It does this billions and billions of times across an enormous data set, and each time it gets it wrong, it adjusts. Over time, through that repetitive process of prediction and adjustment, it gets very good at it. Now, that sounds straightforward, but here's the part that matters for us. This process is statistical pattern matching. It is not reasoning, it is not comprehension, it is not judgment. The model is not thinking. It is estimating, based on everything it has seen, what word most plausibly comes next. And that has a very specific implication that I want you to hold on to. If the model hasn't encountered a situation before, it doesn't pause, it doesn't flag uncertainty, it doesn't say, I don't know. It predicts the next word anyway. That's why these systems can produce fluent, confident sounding responses that are completely incorrect. Not because they're lying, but because they genuinely don't know what they don't know. There is no mechanism for that. Okay, after pre-training, the model can generate language, but it hasn't yet been shaped for practical use. That happens in fine-tuning. In fine-tuning, the model is further trained using carefully selected examples and feedback. That feedback can come from human reviewers, automated systems, or other models that reflect prior human decisions. The goal isn't primarily to add new knowledge. The goal is to shape how the model responds, what kinds of answers are preferred, what to avoid, how to frame things, how to handle sensitive topics. And here's what that means. Fine-tuning reflects human choice, the values, assumptions, and judgments calls made by the people who designed and carried out that process are embedded in the model's behavior. Those choices influence every response you get, even though most users never see how that guidance was created or applied. So when you're using one of these tools, you're not just interacting with a neutral information retrieval system, you're interacting with something that has been deliberately shaped by data, engineering decisions, and by a set of human values you may or may not be aware of. That's training. 5 stages: data collection, pre-processing, embedding, pre-training, and fine-tuning. And across all 5, one thing is consistent. These systems are powerful because they've learned from massive amounts of human language. But that also means they carry forward human gaps, human blind spots, and human limitations. Now, let's talk about what happens in real time when you sit down and actually use one of these tools. So training shapes what the model knows and how it behaves. But that's a one-time process. It happens before you even touch the tool. What happens in real time, every single time you type a prompt and hit send, is a separate process. And it's worth understanding because it tells you a lot about both what these systems can do and where they fall apart. I'm going to walk you through 5 stages of how a large language model actually generates a response. It starts with what you give it. Your prompt, your question, your instruction, your request is what the model works with. Now, I want to be specific about this. The model works only with what is currently in front of it. It doesn't have memory or past conversations unless that information is explicitly included. It doesn't know who you are. It doesn't know your clinical background, your specialty, or the context you're working in unless you tell it. Everything the model generates is conditioned on that available input. So what you put in matters enormously. A vague prompt produces a vague response. A poorly framed question can produce a confident-sounding but misleading answer. The model isn't reading your mind. It's working with exactly what you give it. Now, once you submit your prompt, the first thing the system does is break your input into tokens, those smaller units I mentioned earlier. Words, part of words, punctuation, each token gets converted into a numerical identifier. This is the same process that happens during training, and it carries the same limitation. Your carefully chosen clinical language or nuanced phrasing gets reduced to numbers before the model even processes it. The model is not reading your words the way a human colleague would. It's working with a numerical representation of them. That distinction matters when precision matters. Now, the model processes the full context, everything in the conversation, through multiple layers of its training architecture. Each token gets converted into a numerical vector, and information about word order gets added. So position matters. The model evaluates how every token in the sequence relates to every other token. What this produces is a set of internal representations, the model's best statistical approximation of what the text means, based entirely on patterns it learned during training. It's not comprehension, it's not dimensional pattern recognition, but the result can be impressively sophisticated because those patterns encode a huge amount of information about how human language works. Now, I want to pause on this. This entire process relies on what the model learned during training. There's no new reasoning happening here, no live consultation or external sources, no independent verification. The model is doing incredibly fast, sophisticated pattern matching against a frozen snapshot of what it learned before you ever sat down to use it. Nowadays, some large language models do allow you to connect to the internet for live questions and answers. After processing the context, the model does something very specific. It calculates scores for every possible next token in its vocabulary, and these vocabularies can be enormous, tens of thousands of tokens. Those scores are converted into probabilities. The model asks, in effect, given everything I've just processed, what is the most likely next token? Notice what it's doing. It's calculating likelihood, not truth, not accuracy, not what a qualified professional would say. Likelihood, based on patterns, based on what words tend to follow other words in contexts like this one. This is where fluency and accuracy split apart. The model can produce a response that sounds completely authoritative, well-structured, clinically phrased, confidently stated, because fluency is exactly what it's optimized for. But fluency is not the same as accuracy. And in a clinical or professional context, that distinction is not a minor technical detail. It has real consequences. Once the model selects the next token, it adds that token to the sequence. Then it repeats the entire process. Context processing, probability estimation, token selection, again and again and again. One token at a time until the response is completed. So that paragraph you get back, it wasn't written all at once. It was generated one token at a time, each step based on the probabilities calculated from everything that came before it. The response is built step by step, not retrieved from somewhere. And here's the important implication of that. Because each step is probability based, fluent language can be produced even when information is incomplete, uncertain, or simply incorrect. The model doesn't stop when it reaches the edge of what it knows. It keeps generating because that's what it does. That's the mechanism. So the next time you get an answer from one of these tools that sounds completely settled and confident, remember what just happened. A system trained on patterns in human text estimated, one token at a time, what the most plausible next word was. That is not the same as a qualified professional providing a considered opinion. It's not even close. Let's make this concrete. Suppose I type the following into a prompt box. In therapy, the most important factor for positive outcomes is. Now, if I pause there, many of you are already predicting what comes next. You might be thinking, the therapeutic alliance. Your brain is doing something predictive, filling in the gap based on everything you know. That's essentially what a large language model is doing. It takes the word so far and predicts the most likely next word. It doesn't experience that sentence as meaning, doesn't have any real understanding of what therapy is or what outcomes research shows. It turns the sentence into tokens, processes the patterns it learned during training, and calculates, given these words in this order, what word is statistically most likely to come next. Maybe it selects the word the. So now the sentence becomes, in therapy, the most important factor for positive outcomes is the. Then it repeats the process. What is most likely to come next now? Therapeutic. Then it repeats it again, alliance, and we end up with, in therapy, the most important factor for positive outcomes is the therapeutic alliance. That sounds intelligent, sounds informed, it may even be correct. But the model did not reason its way there. It did not consult evidence. It did not check truth. It calculated probabilities and selected the most likely next word, step by step, based on the data it was trained on and the associations it built between those words. Now let's change the prompt slightly. If I said, in therapy, the most important factor for positive outcomes is lavender aromatherapy, and the model will continue confidently. It might say something about relaxation, stress regulation, or sensory grounding. It won't stop and say, that premise is questionable. It won't flag the research. It won't push back because its job is not to evaluate truth. Its job is to produce a coherent continuation. And it will do that very well, regardless of whether the starting premise is sound. And here's why that matters practically. If a client brings you a printout from one of these tools that says, lavender aromatherapy is the most important factor for positive outcomes, that is not a hypothetical scenario. That is already happening. Clients are arriving to sessions with AI-generated information, AI-generated interpretations, AI-generated advice, and they often have no idea how that response was produced. So now we've seen both sides of the process, how these systems are built and how they generate a response in real time. Let me bring this home in terms of what it actually means for us as psychologists. First, these systems do not reason. They pattern match at massive scale. That sounds like a subtle distinction, but it's not. When you reason, you can identify gaps in your knowledge, sit with uncertainty, and make a judgment call that weighs competing values. When a large language model generates a response, it's doing none of these things. It's estimating the most plausible next word every time. That means the confidence in the response you receive tells you almost nothing about the accuracy of that response. Now, granted, these things do a great job and do look really good and fluent, but that's their job, is to look fluent, not to reason, not to think. Second, the training data shapes everything. What gets included, what gets weighed, what gets filtered, all of that happens before the model ever reached you. And because the model learned from patterns in human language, it carries forward human biases, human gaps, and human blind spots. In psychology, where cultural competency, lived experience, and contextual sensitivity are not optional extras, they're foundational. That matters a lot. In psychology, where cultural competency, lived experiences, and contextual sensitivities are not extras, where they're actually foundational, that matters a lot. Third, fine-tuning shapes how the model behaves in ways you can't fully see. The values, preferences, and the judgment calls of the people who designed that process are embedded in the tool's behavior. That's not necessarily a problem, but it means you should not treat these systems as neutral. They're not. No tool is. Fourth, the model works only with what's in front of it. It has no independent memory, no background knowledge about you, no awareness of what you left unsaid. The quality of what you get out is directly tied to the quality of what you put in. That puts the burden on us as professionals using these tools to be deliberate, specific, and critical about what we ask and how we ask it. And fifth, and this is one that I think is really very important, accountability does not transfer. The model doesn't know what it doesn't know. It doesn't flag uncertainty. It doesn't pause. When something goes wrong, when an AI-generated recommendation causes harm, when a fabricated citation ends up in a report, when a client is given dangerous information, the professional who used the tool is responsible, not the tool, not the company that built it, the human who made the decision to use it and to act on its output without verification and validation. Understanding how these systems work isn't just an intellectual exercise. It's a professional responsibility. Because the more clearly you see what these tools are doing, the better your judgment about when to trust them, when to push back, and when to set them aside entirely. And that's the goal, not to reject AI, not to be afraid of it, to understand the boundaries of when it should be used and when it should not be used, to use it when it's genuinely strong, to hold the line where it's structurally limited, and to keep human judgment, human accountability, and human relationships at the center of our work. So that's the picture. Two processes: training, which shapes what the model knows and how it behaves, and response generating, which is what happens in real time, one token at a time, based on statistical patterns. If you take one thing away from today, let it be this: fluency is not the same as truth. A language model is optimized to produce plausible, well-structured language. That's a genuine strength, but it is not the same as accuracy, professional judgment, or ethical responsibility. And in our field, that distinction is everything. If you want to stay current on AI development in healthcare and psychology without getting overwhelmed, I have a weekly news brief that does exactly that. You can find it at wadeai.com. And if you're in a leadership or decision-making role and you're thinking about how to move from awareness to responsible implementation, that's the conversation I have directly with organizations through my consulting work. You're welcome to reach out at ernest@wadeai.com. As always, if you've enjoyed the show, please subscribe and leave us a review. Feedback is a gift, and we love gifts. We hope you'll join us again.